I'm just going to record it for folks that miss it and stuff. All right, folks. So welcome to our Intro to Unix workshop. What we're going to do is try to work through this. There's a lot of us taking this workshop online, and it's a bit difficult to try to figure out, that everyone's keeping pace and stuff when we're not going through things in class. So we're going to do our best. We also have Nathan Zemke's online with me, and he's going to be hopefully handling all the chat stuff for us, and hopefully that works out. I'm going to try to check in with us every once in a while, or pretty often, and make sure we're kind of keeping up. And I'm also going to try to be mindful of the fact that we're all sitting somewhere, maybe not the most optimal work environments, and give us breaks every hour or so to kind of stand up for 5 minutes and stretch and do whatever else we need. And so this workshop is an Intro to Unix command line workshop. And Unix really is a nice kind of computational Swiss Army knife set of tools that we can do all sorts of things with. And it's really been designed to be workable for folks that have pretty much no computational experience at all. So this is kind of the workshop that I wish, I guess 7 years ago when I got my first, many gigabytes of gzip FASTQ files, and I couldn't do anything with them on my laptop, and I had to figure out how to do this stuff. This is kind of designed for that person kind of moving forward. So it's kind of, what can we get? How can we kind of all become functional? And maybe we're not going to be able to address everything that everyone wants necessarily at any given point in time. We can't handle, in a class of 50 people, what everyone's specific research needs are. But hopefully this is a really nice jumping off point. So in a little while, when you have data, or if you have data now, or if you kind of need to figure out how to use Hoffman or submit jobs or all these other things, you have enough knowledge to really be able to kind of Google or search your way through your very specific problem. And so that's kind of how we've designed this workshop. And just to kind of, hopefully, there we are. And just to kind of, say, here's the slides. Hopefully you all got the slides. If not, I can email them out again to you. I'm a postdoc in the Department of Ecology and Evolutionary Biology in Brad Schaefer's lab. And basically what I am is I'm a conservation biologist and systematist who works on amphibians and reptiles. And so I do completely non-model genomics work for my personal research. And, I'm not a practically trained computational biologist at all. I am someone who's figured out how to use these tools so we can, process the best data possible in the best ways possible, as efficiently as possible, to answer questions dealing with, cute guys like this turtle. And so that's what I do in my personal research. And so that's kind of, hopefully where we're bridging the gap for folks like that, no matter what your kind of personal research sets are. And so what we're going to be doing is kind of working through 3 days of material. The first day is going to be kind of learning the essentials of Unix. And then we're going to talk about Unix kind of fundamentals, the general syntax and usage of stuff. Day 2, we're going to talk about some basic Unix commands, and then talk about getting into some powerful tools that we can process text files with. And then day 3, we're going to go through some more useful processing data commands, talk about shell scripts and what those are, talk about shell scripting and how to set those up. And then we're going to go through and talk about how to submit jobs on the Hoffman cluster for us. And I know maybe we're all sort of waking up and that sort of thing, but what I'm hoping we can do is, did we all get an email maybe a minute or two ago with a pre-quiz? I should have sent out a link to a quick 10-question multiple choice Google form. And hopefully we can all take a few minutes to take this quiz. Did we get that? Can I get any confirmation? We did? Maybe? No, not yet? Okay.
I got it.
You got it. All right. I'm trying to, it's always hard. Yes. Okay. So maybe it's coming through for folks, or if you, okay. So what I would like to do is hopefully we can just pause for 5 or 6 minutes and take this. I'll try to kind of keep with us. This isn't, if you're taking something, this workshop for a grade or anything else, this isn't going to contribute. This is mostly just kind of letting us know a jumping off point for where we're at, and hopefully, helping me assess that, we're hopefully teaching you folks useful things in the end. So is that okay that we kind of take 5 minutes to do that? And let's do that. And then Yep, and then we'll kind of, all right, so I'm gonna start us off on a slideshow here. And basically, I think for the most part, come on. There we go. Hopefully it's gonna wanna work with Zoom. We're gonna be pretty kind of interactive. I hope folks follow along. The first little bit is gonna be more slides and that sort of thing. And then we're gonna get into hopefully kind of, following along with typing commands into terminal and that sort of thing for us. And hopefully this works out pretty well. All right. And so I'm just gonna share my screen and kind of go through things. So, why Unix? I think this is, hopefully we're all here for a reason. Maybe we're here, because we know we want to use these tools. Maybe we're here because, our labs are shut down and we want to learn some new skills. But really the idea is, biological data is getting bigger and bigger and bigger. And our problems we want to do are more and more complex. And so that really requires computational power in many situations that goes beyond what we can do on our laptop, even if we have very nice laptops. I regularly get, gzip text files and genomic data that, are a terabyte or more. And, that's a lot of data. If I unzip that, now I'm talking, 12 or 15 terabytes of text files. I don't have a place to store that personally. And as I go through and process that data, every time I do something to that data, I'm creating intermediate files that are also going to be just as large, if not larger. And so we can, use these large high-performance computing clusters to, manipulate and do things with this sort of data and do analyses and that sort of thing. But those high-performance computing clusters generally use a Unix or Linux operating system like Hoffman 2 or any of, NSF succeeds or TAC or any of these other large high-performance computing clusters are all operating on a Unix and Linux system. And why do we want to use this? Is one, it's very popular. So most programmers use Unix or Linux. So it's really easy to find and get help for our questions here. Also, Unix is really stable. So computers running Unix almost never crash, especially when they're handling, very, very large amounts of data, reading in, huge amounts of data into RAM, for example, they're very stable. Also, it's really efficient. So Unix is kind of meant to be efficient way to compartmentalize many small tasks. And so you can, manage extremely huge amounts of data very efficiently in Unix. And so, for example, it's like, oh yeah, I can, find and replace in Excel or something like that. I've actually tried to clock how long it takes to, do a find and replace in a very large Excel file versus a very large, CSV file, a text file that's basically the same thing, a tabular delimited file. In Unix. And if I want to go through an Excel file that's thousands of columns by thousands of rows and do a find and replace per cell, it might take minutes and minutes to run or tens of minutes. And I can do the exact same thing in a second or two in Unix. And so when you kind of think about when you have really, really large amounts of data, how that scales out. And lastly, most new bioinformatics software is created for Unix. It's designed to be run on high-performance computing clusters via the command line. And so if we don't have these skills, we're kind of missing out on all these new potential softwares we could be using. So the command line interface has some benefits and some drawbacks. I think the main drawback is ease. So we're really learning a new language in a lot of ways. And so when we're using the command line interface versus a GUI is much more visually intuitive. We can look at it. We have drop-down menus that tell us what we want to do. We can always kind of pick out what we want to do by kind of pecking around or clicking around and exploring some sort of graphical user interface. Whereas when we're dealing with a command line interface, we actually have to have some basic understanding what's going on. So we can, we can't kind of intuit our way to a command. Maybe you can kind of guess. A lot of the commands are, kind of have relatively intuitive abbreviations, but they're not always perfect. And so we need to know, oh, if I want to, manipulate my data based on some characteristic of it, grep, and we'll talk about what that is later in a day or two, actually has a kind of nice mnemonic, thoughtful way behind what it's doing. But you know, getting to, oh, I want to use grep versus I want to use find is a different thing from a drop-down menu. However, oh, yep, there we are. You know, the command line interface has tons and tons of benefits. The first being we have way more control over exactly what we want to do in a command line interface. And so, you know, maybe if you're using Arc or something else where you can kind of go through in code, or you can kind of create a bunch of if and or, you know, but statements in Excel, if you know it really well, you have way more control to do exactly what you want to do to your files via the command line interface, because you can type exactly what you want to do. You're not constrained by the limitations of the program designers. You can do tons and tons of great multitasking things in the command line interface. So you have the ability to, you know, just submit jobs and jobs and jobs to, for example, Hoffman, and kind of, you know, wait for them to run when the resources are available. Whereas if you're working on your, you know, laptop, you're only, you know, you're limited by the RAM your computer has, and you have to kind of, you know, only have a certain amount of Excel sheets open, for example, at a given time. Speed. So people actually, it's a lot faster to type commands via the command line interface, especially when you get kind of used to it. So you can actually go through and manipulate data much more quickly from your standpoint as well. So as opposed to taking the time to open up 40 Excel spreadsheets and find and replace whatever character you want in each one of those and save them as a new file, you know, you can write very quickly a couple of lines that'll go through 40, you know, tabular delimited text files and do the exact same thing in a matter of seconds. And so it actually makes your work much more efficient using the command line interface. You know, you can do all sorts of scripting, like we said, and this allows you to execute all sorts of specific programs in some pretty complicated ways and do that uniformly over, you know, hundreds or tens or thousands of files if you want to. And you can't do that at all in your kind of graphical user interface programs. And then you have a lot more diversity as far as what you want to do. And so, you know, every GUI is kind of designed to do things differently. You know, everyone complains when Microsoft Office comes out with a new release and everything's different from how it was before. And the command line interface is generally really kind of back compatible. And we'll kind of see examples of that as well. You know, so you kind of, you know, most programmers kind of remember people, you know, are used to typing things certain ways. And so they kind of, even if a tool has a major change, they kind of remember, oh, this is how it used to be. And they kind of write stuff in ways that you can kind of go through and have that back compatibility, which is great. And then strain, actually, people say, you know, typing things on your keyboard, you know, via the command line interface is actually much better for your body than it is, you know, kind of mousing around. And so people actually, you know, see that folks actually have a lot less chance of carpal tunnel and that sort of thing, you know, when they're kind of typing their own programs. And so there's a lot of benefits to using Unix or Linux over the command line interface. And they can be, you know, really, really helpful for us. And the whole idea is we're trying to, you know, do things with our data as efficiently as possible, as quickly as possible, and saving ourselves kind of the most amount of time as possible. And so what we're going to try to do in this class is give you enough knowledge in the class to kind of get yourself started. And hopefully what that'll do is be a really nice springboard for you and your personal projects to be able to use things like Google or Stack Overflow or Seek Answers or a bunch of other free online resources to get at your specific problem. So you can really, you know, manipulate your data as quickly as possible. And so we might not address every way we want to, you know, sort a file, you know, by some file characteristic, for example, but, you know, hopefully we've given you enough information about how to sort files and the general syntax for that, that you can then very quickly Google, you know, I want to do this, how do I do it? And then you kind of have the right syntax to do that as well for yourself. All right. And so I think it's useful to kind of go through and start talking about the infrastructure of our different computers and how these work. And hopefully this kind of gets us into a good place. Are we all doing okay wise? Are we all keeping up? I don't want to like share everyone's chats, but you know, I want to make sure our pace is okay. Um, and so what's Hoffman 2 is? Hoffman 2 is a general high performance computing cluster. It looks like most other high performance computing clusters, although all of them are set up and they all behave a little bit differently. But the whole idea is you have your user terminal, which is going to be your laptop or your iPad or whatever else you want. You're going to log into Hoffman via a bunch of login nodes. And then via these login nodes, you can connect to a bunch of computational and storage nodes. And so we never want to actually be running big things in our login nodes. But what we're going to do is we're kind of using these login nodes as an intermediary between the really powerful stuff that's part of the Hoffman cluster and our computers themselves. So we're going to log into our login nodes. The login nodes might be where we keep scripts. They might be where we keep smaller data files. We have some scratch files. And then what we're really going to do, though, is use these login nodes to communicate and submit jobs on these high performance computing nodes. And so we're going to maybe say, you know, I have a bunch of files here. I want to perform something to them. I'm going to write a little script. I'm going to submit it. And that script is going to run using these computationally heavy nodes. And so that's kind of the infrastructure of most high performance computing clusters, including Hoffman. And so how do we connect to Hoffman? And we're going to kind of jump right in here. I'm actually in the show just so, just so I can kind of, there we are, show you multiple things at once. And so here, I'm going to open up. And so what we're going to do when we want to connect to Hoffman is hopefully we've all figured out how to get some sort of secure shell. This is what SSH means, secure shell, program to connect us to Hoffman. If you are working on a Mac, that's going to be your general terminal. That will work fine. And the reason why that'll work fine is because Mac's operating systems are Unix based. And so the general syntax works. If you are on a Windows machine, or if you're on a Linux machine, then you're totally fine. If you're on a Windows machine, you're going to need to use some sort of open SSH program. Hopefully you all got the links I sent out. I prefer Sigwin, but that probably is just because that's what I originally learned on. Other folks really like Putty. There's other ones of these. But the general kind of way we're going to connect to Hoffman is we'll open up one of these SSH programs. I'm going to make my my text way bigger so we can see it. And we're just going to type the general command SSH, whatever your username is, and then the address for where we want to go. And so I'm going to try to, hopefully we can follow along here. And this is where we're going to get kind of into the, hopefully we're following along with stuff, typing commands as we would, or as I'm doing it as well. And hopefully the pace is okay. And, you know, let me know if our pace is off. You can all turn on your microphones and shout at me, or try to get in the chat. And so the general command is just SSH. I'm going to type my username on Hoffman. You type yours there. And so it's, you know, Hoffman2, IDRE, UCLA.edu, and that's the address of where Hoffman's login nodes are kept. We hit enter, it asks me for a password. I'm going to type my password, and you're going to notice nothing is showing up. That is for security reasons, but it's there. And we're hopefully logging in. And we get, you know, a little welcome to the Hoffman cluster. It tells us where support information is. It tells us all nodes need to be accessed here. It says, please do not compute things on login nodes. And then it gives us a warning that these processes running on the login nodes degrade others' use of the system, and they will get terminated with that warning, and they'll get killed. And they, you know, so that's a bummer. And, you know, that's some other information. is there. And so you want to be respectful of the login nodes. You know, if you're running something big, then other people can't do stuff. Yep. And, you know, Hoffman's folks are pretty nice. They realize it's a university. They realize not everyone knows everything. You know, generally your job will just get killed. Sometimes you'll get an email from the administrators if you run a job on the login node. Other high performance computing clusters, folks are actually quite a bit more grumpy, and you'll get kind of an angry nastygram email, you know, warning you not to do that again, or maybe they'll, you know, ban you for a week or something like that. So Hoffman folks are nice, pretty nice at least. Yeah, so on maybe a Mac machine, we're using, you know, our terminal. On a Windows machine, like I said, we're using PuTTY or Cygwin, or if we have, there's Ubuntu for Windows, which is a new kind of thing you can run on Windows 10, but hopefully we've kind of figured out some of this stuff. I'm just gonna check and make sure we're all. Yeah, so when I say computing things on the login node, that was a good question. Generally, what I mean is running large RAM tasks that use a bit of time. So you can do basic manipulations of files. You can edit files. You can change files. What I'm talking about, is if I have a bunch of FASTQ files that I want to map to a reference genome. I don't do that on the login node. I don't perform anything that's going to eat up a fair bit of RAM and use a fair bit of time. You don't want to do in the login node. The other thing about the login nodes are when I close that connection to Hoffman, those nodes or whatever job is running or whatever thing is open that's not saved disappears forever. However, when we submit a job, which we'll talk about in a few days, that job kind of sits in a queue without me being logged onto Hoffman and will start when it's ready to get started. And so that's another benefit there, hopefully. So if we are using PuTTY and we haven't done this yet, the host name or IP address is going to be hoffman2idre.ucla.edu. We're going to use port 22, and that's the security of the port. That's standard. We can save our session. So if we want to have it called something we can use later, we can do that. And when you log in for the first time, it's going to ask you about a fingerprint for the address. You want to say yes and save that. In the same way, this is what we just did with Cygwin, and hopefully we're there. Are we all logged in at least? Most of us. Oh, yeah. So the password is going to be whatever the password you have that you either got from the administrator or changed. Yep, and when you get that warning about the RSA key fingerprint, you want to say yes, and that's just your computer's way of saying, I haven't logged in here, I don't recognize this computer. Do you trust this connection? And so you have to say yes there. Hopefully that works. All right. And so what is a Unix shell? Now, hopefully we all have a Unix shell. What is this? And the shell is just a program that waits for you to type a command and execute it. The general command here, or the kind of general syntax is you just type any command in the Unix language and hit return. So the general basic syntax here is, program, utility, language, whatever it wants to be, plus flags, and the flags are going to be modifiers for that command. So maybe, I want to do something, but only uppercase, and there maybe is a specific program flag for that, and then plus a file that you want to work on. And so, the most kind of basic example of this would be a command ls, and ls means list. I'm adding the flag long which is dash lowercase l. And then we'll talk about what a wildcard is, and then I'm asking for it to list the long form of every text file that I have. And so I have, come on. How's that not going? Come on. No, my terminal is not happy with me. Okay, that's why. So if I type ls flag L star or asterisk text, I actually have a bunch of text files, where I'm at here. And we'll talk about what all this stuff means in a little bit. But that's kind of the general syntax of everything we're doing via the command line. Within this Unix file system, and this is kind of the general working address of how all these things work. And so everything we're typing is going to be relative to where we're at on that computer cluster. And so when we log in, we actually log into Hoffman in our home directory. So we're not kind of starting at the base. We're starting somewhere kind of nested up in the file directory system. But that's where we start off. And so on Hoffman 2, we all start off at U, which is for users, home. There is a single letter abbreviation for the start of your username, and then your username. So when I start off on Hoffman, my address on the computer is U home P Scott 17. And within kind of the Unix file system, if you kind of start at the base, you end up with bin, etc., user, and these are going to be directories or places on the computer that tell the computer how to act. And then within home, we can have potentially a bunch of users. And then within each one of these users, you can have all your own subdirectories that you want to start off with. And so where you're at on the computer is called the path. And so if I want to perform a task in my home directory and on a file, that file also needs to be in that home directory, or I have to tell the computer where that file is relative to where I'm at. And so hopefully that works. Make sure. Yep. Yeah, so that's right. So this is all correct. Yep. All right. So when you log into Hoffman, you always start off in your home directory, and you want to create subdirectories in places that specific for projects or groups or information or types of things. You don't want to accumulate tons and tons of things in your home directory, just like you don't want to accumulate tons and tons of things on your computer desktop. So I'm not going to type this, but for those of you that just got a new Hoffman account and you have a default password, you want to change your password, and we're going to use the command for that password. And so all you type is passwd. It'll ask you to enter your current password, and then it'll ask you to enter what your new password you want is to be. And so this is something we don't need to necessarily do right now. You want to make sure you remember it. But as we kind of saw before, or if we had trouble logging in, unlike even things like your bank or your iTunes account or whatever else, you can't kind of get an email to reset your password right away, because the Hoffman folks care quite a bit about security. If you lose your password, you actually have to go through them to have it reset again. And the temporary password you got when you created your Hoffman account is going to expire after a little bit of time. And so you want to, make sure, you kind of keep up with that. And so this is how you'd change your password. And this is the same on every Linux operating system. This is a Linux system command. It's not a Hoffman command, but this is how you would do that. And so what we're going to do is we're just going to kind of go through some basic Unix commands here and kind of learn about kind of the syntax of how we're going to move around our file directory systems. And so the first one of these commands, which is nice, is pwd. And what this is it stands for the path to my working directory. And the working directory is where you are on the computer at any given point. And so right now, I'm hopefully logged in. And you can see I'm logged in. So you can actually see here's where I'm at on Hoffman. So I'm at pscott17, that's my user. I'm at login 4. So there's multiple login nodes on Hoffman, and they kind of try to distribute when you log in, where you go based on kind of not overloading the system. And so that's where I'm at. And then the tilde here is actually means home. And so I type path working directory and hit enter. It's going to tell me I'm at, U home pscott17, which is where, I should be, hopefully, if I haven't moved around. And we're hopefully okay there. Keep up. Do we want to wait a moment? It's always hard for me to figure out where we're at or how we're doing. For folks with their cameras on, are we up to space? Okay. I'm trusting you guys then, unless, yep. Unless I hear elsewhere, we're moving. All right. So the next command we're going to learn is one called mkdir, make directory. And this is going to make a directory. And so, directory is just the proper term for a folder. Like if we had, make a new folder, using right click on our laptops. And so I'm going to make a directory called test. And so I just type make directory, and then the next thing that follows is going to be the name of that directory. I'm going to call this test. I think I'm going to get an error because I made sure all this worked the other day. We'll talk about that in a minute. Oh gosh, sorry. Okay, don't worry about that magic. So make directory test. And this is nice. We got no error message, which means the command was run successfully. And that's good. And that's kind of the general syntax as well of what's going on, or how Unix generally behaves. The scary thing about that is the computer is literal. And so if you don't have a typo in your script, that's fine. And it will run. However, it might not do always what exactly you think you're wanting it to do. And so, if I, mistyped test and I said make directory tset, it still makes that directory. And it actually made that other directory as well. But if I wanted to then do something to the directory test, it's not there. And I don't know it's not there, because I got no error message. And so that's, just kind of the general syntax of how all this stuff works. The next command we're going to learn is cd, and this is change directory. And so we can do cd test. And I can now type path working directory. And we can see now in this file system, I've gone up one directory. So now I'm in pscott17, and you'd be in whatever your username is in the folder or directory called test. And that's nice. Or hopefully feels nice. And so when we're moving through our directory file system, we're kind of moving up into the file system, or I guess down into the file system is the proper term. So when I'm in test, I'm kind of down a directory than my previous directory. And so there's a couple ways to go home if I wanted to go home. The first is I could do cd tilde. And so, and the nice thing too here is it actually shows you, I should have said this, is in the login node 4, it actually tells you your exact directory position at this point. So now I'm in test. And if we noticed before, remember I said home is also tilde. So the tilde is a shortcut for home. So I can do cd tilde, and it's brought me home. And if I type pwd, I can now see that's where I'm at. And so if you ever get lost, as opposed to clicking your heels like Dorothy, you can cd tilde and you can get home. If I go back into test, which now I'm back in a test, path working directory, if you don't believe me. The other way to move around is you go cd period means take me to the directory above where I'm at. And so in this situation, that's also home. So now I've moved back out of file system, kind of up one directory. It won't always take me home. So I could do cd ... again, and now I'm in P. So my path working directory is in the home folder for everyone whose username starts with a P. I can go cd pscott17 to move myself back into my directory, or I can do cd tilde. And I'm home again. Hopefully that works. Oh. And I guess I just ran through all that practice. Sorry, folks, but if you want to give it a second to play around. All right. So as we're, manipulating ourselves around the Unix file system, here's a couple tips for us. If we want to go back to the previously entered commands, we can use our up and down arrows. So if I hit my up arrow, I'm at path working directory. The command I hit before that was cd tilde, path working directory, cd ... etc. So if I had a command that I liked, I can fix that, or I can go back up to it. The other thing is it's useful if you have a long command that you typed out and you realized you got a typo in it. So, if I realized I created the wrong directory, I created a directory called tset and not test, I can go up to that last command I typed, fix that typo, and hit enter. Although I'm going to get an error here because I already have a directory called test, and it's protecting me from myself. The other thing that's really nice is we can use tab to auto-complete file names or directory names, etc. And so this is really useful if I want to go, I don't always follow my own advice, but if I just show you everything that's in my home directory, there's a lot of stuff there. And let's say I wanted to, type out this whole long tar tg root folder. I don't want it to type that whole thing out, but you can see actually there I typed RO and then tab, and I got a list of everything that started with root or RO in my directory. And actually that's not executable, so it wouldn't let me run it. But if I wanted to go cd into that root folder, so cd root, and I hit tab and I got a little bit. And then if I do V6 and I hit tab again, it auto completes out the rest of that for me. And so this can be a really useful way to kind of type things pretty rapidly. The same way I want to go into SAM tools. There it is. So I've typed it out, I've completed it. It's been pretty easy. And hopefully that's useful for us. And so you're gonna kind of notice that I tend to do a lot of tab completing, and it makes stuff pretty quick. And it also prevents typos, because you guys will notice I type a lot of typos. And so when you're tab completing, you're not, risking putting a typo in something. The other thing is if you're stuck with a command, and so, Unix expects that you're typing a complete command every time, but that's not always the case, especially if you're kind of learning a program or a tool for the first time. And so maybe you've left off a flag or a modifier or a folder you want to act on. You're going to end up with, let's see if I can, I'll just try to think of something, a good one. So, I just used the command grep. I was grepping for something, and we'll talk about what all this means in the next day or so. And what happened is I have now a blinking cursor over here, and that's, basically the computer's way of saying, hey, I'm waiting for you to finish what you want to tell me. You told me to do something, but you didn't tell me a file to act upon in this situation, and that's what we're missing. And so this, kind of cursor over here is akin to the old school, spinning wheel of death when your computer got frozen. How do I get out of this? I'm going to do Control C on a Linux or Windows, or Control Z on a Mac. And that should get us out. So Control C at the same time, and now I'm back to my $sign, waiting for a new command again. And so that's always, if you get stuck, the computer's just saying like, hey, I'm waiting for the next thing to do. That's a good way to get out of that. All right. So, so if we kind of want to just, see how this stuff all works one more time. So if we do cd test, and now I can make another directory within test. I'm going to call this one new directory. I'll hit enter. cd new directory. So now I've moved up into that new directory, and I can see, now I'm in new directory, but I don't know where I'm at relative to everything else. I can do path working directory, and it tells me where I'm at. And if I wanted to get back to home, there's a lot of ways I could do that now. I could do cd tilde. I could do cd ... hit enter, cd ... and hit enter again, or everything we're working on is relational and can be strung together. So cd ... /... means take me up 2 directories. So if I enter there, now I'm home again. Hopefully that works. So the next thing we're going to want to maybe do is talk about creating a new text file. And I am going to use the most basic text editor. And so in this text editor is called Nano, that kind of exists, I think, on the Unix platform. This is like opening up, Notepad or something on our computers. But it allows me to create a text file in terminal. And so when I open up the tool Nano, now I'm actually going to be inside a text editor in my terminal. And so now what I'm typing is going to go into that text file, not be a command that's addressing the Hoffman cluster. And so if I do nano, oh, and I realize here, so at least here I'm going to move back up into my test file, just so I'm not creating a bunch of garbage in my home directory. And so I'm going to type nano test.txt. And so here, and I like nano because it's really relatively intuitive to use. It tells you what it expects to use. And it's a little bit foolproof as far as what you're doing when you're working with files. There's lots of other text editors. Lots of people like a program or a text editor called V. There's a modified V called Vim. They're very popular. You can do a lot of kind of fun stuff, especially if you're coding, as far as color coding things and making sure your syntax matches and is appropriate. But it also is a much steeper learning curve. And so if that's something that is going to be useful for you, by all means, go get into it. If all you need to do is create some basic scripts, Nano is probably good enough. And so what I'm going to type is, I'm going to type Nano, and I'm going to type test.text. And what I'm doing here is I'm naming a text file, test.text, and I'm naming it at the beginning. I could have also just typed Nano, and it would bring me into a text editor without creating a file. I'm going to exit out of that, but I'm going to kind of try to get us into good practice. So I'm creating a text file called text, and I'm going to hit enter. And so we can see now I'm in Nano. I'm in the file text.text. And down at the bottom, it's actually telling me a bunch of different things we can do to modify this text. And all the up arrows mean control. And so we can type something. I'm going to type my first text file. Hooray. It's a lie, but that's what I'm typing. I'm going to type Control Alt O, and this means write to the standard output. And it actually is telling me here's a prompt. Do you want to write to this file? I'm going to hit enter. I wrote one line, and this is akin to saying save. So I'm writing out to this text file. And so now I've saved this line in this text file. And I'm going to press Control X to exit, and it took me out of that. If I up arrow, I can go back into nanotest.text. It's there. If I wanted to do something like, I'm just going to write line 2. I could write Control O to write that out to save it. Or if I do Control X, it's going to ask me, do I want to save this file? If I hit N, it won't save line 2. If I hit Y, it will save line 2. And if I hit Control C, it'll cancel it. So here, I'm going to write no. I hit N, and I didn't save that thing that I wrote line 2. And so there's kind of lots of ways here we can, exit out of files, and it always kind of asks you, do you want to save this? What do you want to write the file to, et cetera, et cetera. And so that's kind of nice. And so, if I go back into, if I do this again, I do exit, I do want to save it. And now it's saying, what do I want to write it to? Do I want to write to the first original file or to something else? And so it can be really helpful for us. Hopefully that's nice. And are we with me for the most part here? I think we're pretty much there. So like I promised, I'm going to try not to, drive us crazy. I think we take a 5-minute break. So if it's 10:02, maybe 10:07, let's get back together. And this allows us kind of have a quick bathroom break, stretch, get more coffee, etc. And then we'll kind of get back to it with the next set of commands. Hopefully that works for us. And we'll get back to it in a few minutes. Oops, should have done that. And so, we can string all these ls commands together. And in this case, H doesn't make a difference. Just to show you, if I do lslh here, so like here's some things I have. These zip directories are now megabytes, for example. And then if you have stuff that's large, you'll get a G for gigs or a T for terabytes, although you don't have that much space on your home directory. So now I've moved back into test. And so if we want to know more, you don't want to rely just upon me for understanding, you know, all the different things we can do with these tools, we can check the manual and we can Google them. So if we want to know, you know, for example, very specifically, how do I list, you know, by file size, or how do I list by modification date? You know, you just Google, you know, list files by date, you know, Unix, and you'll get, you know, someone's explained how or why or what to do. The other thing that's really nice with all these tools is the command man, which is just short for manual. And all you do is then ask for the manual for the given tool you want, and you can see all the different things you can do with it. So if I type man ls, it's opened up the manual for this. It tells me the name of it. It's ls, list the directory contents. It tells us the synopsis. So this is the syntax for the program. So here we're going to list all the options, and then we want potentially files. List information about the files, sorts alphabetically if there's nothing there, and we can kind of roll through and see all the different possible flags we can use it. So you can give it like flag little a is to do not ignore entries starting with a dot. And so these entries that start with a dot, or files that start with a dot, are generally systems files that tell your computer how to behave. And if you want to see them, they're generally hidden from you, but you can see them if you want to. And then we can also see something else about how these flags work. Is there's generally multiple ways to call a specific modifier for a program. Generally, we can have a single dash followed by a letter, or a double dash followed by a more explicit verbal command of that. So single flag A is the same thing as typing dash dash all. And those are the same. And we can then see all the different things that we can do with ls if we wanted to. And there's lots of different modifiers. I just gave you a few of my favorites. And this is generally how all these things work. You know, lots of information. And all we're doing here is, you know, this is a very, you know, easy little program. It's just a program to list what's there. And there's all this information about what we can do if we want to. And if I want to get out of the manual, I can type a Q, and that should work, I think, for most folks, or Control Z on a Mac. Oh, and there's actually multiple LSs on the computer. So it took me through 2. So I typed QQ. And, you know, like I said, then, you know, we can do ls, you know, I want to sort by data. So, or by, that should be date. And so I can Google that, and I can figure out, you know, I want to ls by time. And then if I want to reverse time, here's the other option. And this is, you know, the first link from super user. And so there's all sorts of forums for folks that use Unix and Linux, you know, super users, Stack Exchange. There's a bunch of biology specific ones, but it's always better to search first than ask the question again. So one other nice thing about our general syntax we can use is the asterisk. And so the asterisk can be used as a wildcard. And so we can type ls, you know, wildcard text, and that will match, in this case, test.txt, because it's matching anything that kind of ends in txt. We can type ls t asterisk t, and that will match anything that starts and ends in a t. And in this situation, it's actually saying this file starts with a t in test and ends in a t in text. It's not actually matching the internal matches here. This is the beginning and end. And then lastly, we could do ls t star, and this will list anything that starts with a t. Hopefully that works for us. And so there are various ways to display the contents of a file. I guess maybe we can run through those. So, you know, T So ls, t asterisk t, I'm getting the match here, test.text. ls asterisk dot txt is going to display all text files that I have. That works. If we did this, for example, t asterisk x, although that is found a couple places here in this file, it won't list me anything because this is an exact match for a file that starts and ends in X. So hopefully that works for us. There are also lots and lots of ways to see what's in a file in Unix. And this can be helpful because we don't always want to open especially a very large file using nano or V or anything else. Just like if you try to open, a multi-gig text file on your computer, it'll take forever to open. The same thing is the case in Unix. So there's lots of different ways to see what's in a file. One is cat, and so that concatenates the file, and concatenate is just going to print it to the standard output, and it'll print the whole file. We can less a file, and this is going to allow us to scroll through a file, kind of starting at the top and moving through it. We can take the head of a file, and this is going to allow us to display what's in the top of a file. And lastly, we can tail a file, and this allows us to see what's at the bottom of a file. I see lots of chats coming through. I just want to make sure we're in good shape. All right, I think we're good. Okay, cool. So we're going to kind of scroll through some of these and kind of learn how they differ and how we can use them. So the command cat is going to dump the entire file to standard output. It's good for displaying short and simple files. So, if I do cat test.text, it printed it out, and there you can see I saved that line too. So it dumped it out. I'm just going to scroll back just to see if I have any large. What do I have here? I don't think I have any really large text files here. Yeah, that's fine. We'll get there in a second. If you have a really large text file though, and you cat that text file, it's just going to scroll through it, looking just like the matrix or something like that, just like a file, 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 file. And if it's a very large file, it will go until it reaches the end of the file, which is not always good, especially if you have files that have millions and millions of lines, which you might. And so if you accidentally cat a very large file like that, you can terminate the process by doing Control-C. The command less is great because it allows you to scroll through a file without a mouse. You're using just the up and down arrows, and then you'll quit using Q or Control-Z, just like depending on what operating system you're on. So let's kind of see how these things work. And what we're going to do is we're going to type this command printf. We're going to give it some quotes, a $S and N, some numbers, and then we're going to create a file called large text. And we'll talk more about what all is going on here. But for now, it's just going to be a way that we can create a file for us to fool around with. Printf. And those are curly brackets around the 1 and 300. So 1.300. Whoop. So all we're doing is we're using a conditional print. We're saying print the character that's coming followed by a new line, and we'll talk more about all this stuff. So that's basically return. And the number that's coming is going to be all numbers between 1 and 300. And then we're directing our output to large text. And we're going to talk, we'll break all this stuff out more and more as we go through over the next few days. But that's all we're doing. So all we're doing here is we're creating a file called large text that's going to be a list of all the numbers 1 through 300. I hit enter. I don't get an error. I feel pretty good about myself, hopefully. I'll leave that up for a second. And then we can kind of see how these things work. So if we head large text, it's going to list me the default behavior of head is to list me the first 10 lines of a file. And so here's 1, 2, 3, 4, down to 10 like we wanted. Great. If I tail large.text, it's going to give me the last 10 lines of a file. That's the default behavior. And then like everything else, all these tools have different modifiers. So if I wanted to get just the last 3 lines of the text file, we can type tail. Now the flag N is for number, 3 lines. So I'm modifying this flag in tail, and I'm getting large text. And I'm getting just the last 3 lines. And so that's what we expect. You can see if I were to do cat large text, it just spits through them. It spit through them so quickly that I got down to the bottom of it. But if we scrolled up in terminal, we can see it's all there. In the same way, if I went into nano large text, now I've opened it and I could edit it. None of those things will allow me to edit it. But if this is a very, very large file, maybe nano takes, 10 minutes to open or something, and that's a real pain. Building all right. Yeah, so someone was asking for cat again. So cat large.text, it just prints it to the standard output. We can't edit it with this. And then we kind of didn't talk about it. And this is one that I like, is we can do less large.text. And this actually allows us to scroll through it up and down using my up and down arrow keys. So it's all there, but it just kind of allows me to scroll through it a little bit by a little bit. And so I can scroll all the way down if I wanted to. When I'm done looking at the file contents, I just hit Q and I'm back. Hopefully that's okay. So that's kind of how we can see what's in a file, how we can make a file, how we can, navigate around the Unix file system. We can actually do things to files, and the first ones of these that we're going to talk about, or the main ones, are CP for copying a file, MV for moving a file, and RM for removing a file. And we want to be really careful here, especially with RM, because generally when we remove a file using RM, it's not like we're putting something in our wastebasket on our laptop that we can go and open up that wastebasket and pull it out. It's deleting it permanently. Although the Hoffman folks specifically have a way to potentially recover things. It looks like they have some sort of buffer on saving files. This is the only high performance computing cluster I've worked on that offers this sort of service. And I don't know how reliable it is. I've never used it, but if you end up in a bind, it's worth checking. So the general syntax of copy is CP, the source, and the destination. And there's lots of flags we can use as well. We can make it interactive. We can make it recursive. We can force issues. We can make it verbose. And so if we want to practice, we can copy, if we're in test, the folder test or directory test, we can copy, I think I called it now text.text, and maybe I want to call it text1.text. And so here I'm just saying I'm copying text.text into text1.text. I hit enter. I didn't get any errors. If I type ls, now we can see we have large text, we have our new directory, we have text1, and we have text. Hopefully we feel relatively good about that. We can make a new directory. So we're going to use the command make directory. We're going to call it new. If I wanted to copy that directory into a directory called new2, I can hit enter, and we get an error. And this says copy, we're omitting the directory new. And so we need to use a modifier here, or a flag. And we're going to use the flag R, and R means recursive. And that means do it to the directory and everything that comes with inside of it. So I'm going to just up arrow because I don't want it to type that whole thing out again. And now I'm copying recursively new to new2. And I hit enter. And if we hit ls, hopefully that works. And so now we have 3 directories, 3 text files. And hopefully we're feeling relatively good about ourselves. The last thing we can do is, which is kind of nice, is we can copy and we can redirect things to where we want to put them. So I can copy, in this case is going to be text.text, and I'm going to try to copy this text file to the directory new2. And here it actually understands that new2 is a directory, not a new file. And I hit enter, and that should work. And so what we're doing is we're copying the text.text into the directory new2. I can also be more specific, and I can copy text.text, and I'm going to copy it into new2, but I'm going to call it text new.text. And so now I'm telling it specifically, I want to copy this file into this directory and rename that file this name. And I can enter. And I can cd into new2. And if I hit ls, I have both of those new text files there. And so now we're talking a little bit about redirecting and how to copy things. And hopefully this seems okay. Now I'm going to check here. Yeah. All right. I think we're doing pretty good. All right. Yep. All right. So that's that. And we can move. Yeah. So someone on the chat was asking about directories that are above a directory and that sort of thing. Can you copy? Can you move? Yes. So as long as you specify specific paths of where you want to go, you can put stuff all over the place. You just have to be as specific as possible. If I wanted to copy something home, you know, for example, I can go copy tilde, and then if I knew I had a new directory here, you know, test2 or whatever I wanted to call it, you know, some stuff, etc., etc. You know, I could do as much craziness as I want here, and that's really helpful. And maybe this is a good time. I'm going to kind of give us an aside that I don't have a slide for, but maybe this is a good time to talk about it. Is so far we've been working just with our home directory on Hoffman. We also have been given a scratch directory on Hoffman, and this is kind of our big working directory. And so our home directory, I can't remember what the limit is. It has a limit of, you know, 500 gigs or something. It's not too, or no, it's way smaller than that, 50 gigs. I can't remember. You can't put that much there. but we have a Scratch directory, which we can use on Hoffman. And that is going to be located, and we all have our own Scratch directory, and how to get there is we do CD $, because there's a symbolic link. We'll talk more about that. CD Scratch. If I hit enter, oh, it did. Okay. So now I'm not in home anymore. I'm in U Scratch, and then the file system's the same way. And here you can put up to a terabyte of things. So it's quite a bit of data. You can read and write to that. You can redirect things back and forth, etc., to that Scratch directory just fine. The one scary thing about the Scratch directory is they purge these Scratch directories quite often, every week or two. And so anything you haven't worked on in a week gets, or maybe 2 weeks, gets deleted from the Scratch directory. And so that can be a scary place to leave stuff. You don't ever want to use it for permanent storage, but it's a fantastic place to write outputs to. So you can read from your Scratch directory, and you can write to that Scratch directory. The same way you can copy from wherever we're at. So if I would go CD home, CD test, I can copy text.txt, and I'm going to copy it to my Scratch directory. And now I've moved text.txt to Scratch, or I've copied it there also. So you can, it's completely relative, and it would make no difference if I did that versus if I did this. Here I've told it the absolute path to my Scratch directory, or here I've given it a shortcut, just like the tilde is a shortcut for home. And both of those things would work just fine, or would work the same way. All right. And we're doing okay? All right, cool. All right, so the next tool is the command move, and it works just like copy, except for it's actually moving something. So it's moving a file from one place to somewhere else permanently. So let's see. Oh, I guess I'm directory. All right, so I'm in test where I want to be, so I can move text1.txt to new. Oh, and I of course had a typo. And so now if I type ls, I don't have text1.txt anymore, because now it's in the new directory, or the directory named new. And you can use move to rename, or that's the proper way to rename things as well. So if I do move, and I'm going to move text, but I'm going to not move it to a new directory, I'm going to say, I'll call it test rename.txt. And if I hit enter now and type ls, what we can see is before this file that was text.txt is no longer there, but we have test renamed text there. And so I've renamed this file by moving it. I've basically moved it to another file with the new name. And you can, move things and rename them at the same time, or move them into directories, etc., back and forth and rename them. Just like, so it'd be the last thing we could do is, I think I removed it. So now we haven't done, or we've done copy. I'm just copying it to a new thing. And so I can move, I'm copying test rename to test. And I can move test.txt to new. And then I'm going to call it test2.txt. And so I'm moving it and renaming it at the same time. And hopefully if we go into new, we hit ls, we have both test1 or text1 and test2 there. And hopefully that works for us. All right. So we've kind of experienced these a little bit already with the tilde and with the $ scratch. And so we can create a symbolic link, and a symbolic link is a special file that points to another file. And so the idea here is you have original data somewhere on your hard disk. Maybe it's in Scratch. Maybe your PI's purchased some permanent storage on Hoffman that you can keep things on. And then we're going to create a link that takes us to that data. But we don't have to type out the full path every time to where that data is. And so you can perform operations on the link name just as you would the original file. But you don't want to, and you can do normal things to that symbolic link as well. You can copy it, you can remove it, etc. But you don't want to modify the data through that original link. So for example, maybe your lab group has a bunch of reference genomes sitting somewhere in your private storage on Hoffman. You don't want to have to type out the full path to where that reference genome is every time you want to do something or use a program that needs that reference genome, but you can create a symbolic link called something like reference in your home directory that takes you through to that path every time. And so that's something that, I potentially do. And so to kind of show us how this works, so we're in new. We can create a link, and now this is LN, not LS. I'm asking for the link to be symbolic. I'm telling it now my path. And I'm going to use tabs when possible to prevent myself from doing typos. So I'm creating in the directory new a link to the directory new2, and I'm going to call it new2. And if I type ls, we can actually see now I have new2 here in this directory, and new2 is basically instructions for where that is. So I can do something, for example, like typing less new2 test.txt, and it performed the operation less on the file test.txt in the directory new2 without having to type out this whole path, right? There's lots of other ways I could have done that. I could have done, less ... new2 and hit enter. It would have done the same thing. I could have typed less tilde test new2 test.txt, and it would do the same thing. But I'm going through that symbolic link, which is basically providing myself a shortcut for this path. And so that can be something really useful for us to use. Are we all sort of with us? Yeah, and so depending on, so just for some folks, depending on what you're doing, sometimes you end up with these different links and stuff being different colors and that sort of thing. You can change the default behaviors of your terminals to show them differently, or if you're using like Cygwin or Terminal, sometimes they come up differently. All right. So the last kind of file management tool we're going to use is RM, and this is going to be remove. And just like for copying or moving, we can use the flag R for making it recursive, which we need to use on a directory. And so to see how this works, so we'll do cd tilde test new 2. And we should have text.text in there. So we can do rm text.text. And we hit ls. Now it's gone. It's gone forever. If we do cd ... so we're moving back a directory to test, and ls, we'll see what's there. If we wanted to remove everything, if we wanted to remove new 2 and everything that's in it, we could try typing that. It's going to tell it can't remove it because it's a directory. If we go back into it, it's not just not removing that because it's a directory. It's not removing what that directory contains, but we can type remove flag r recursive new 2 and hit enter, and it's gone, and it's probably gone forever. And so we want to be really careful when we're using RM because, you know, it's gone forever. And so, you know, typing something like rm star.text is a very, very scary thing because you could remove all the text files that you have. And that would probably be a bummer. And so, you know, we want to be careful with RM. And so what's kind of nice, and like I said, you know, copy, move, remove can work on many files at once. So we can copy multiple files to the directory new. We can remove a bunch of files at the same time. And we can use the wildcard with them as well. So we could remove, like I said, all the text files. We could remove all files that start with L and end in S. We could remove all files that start with F. We could move all files that start with F into new, etc. And so that's nice that you can perform, you know, batch operations. You know, oftentimes you might want to, you create a bunch of text files and you want to move them all somewhere called, you know, output or something like that. You can just move all my text files to out or output. All right. How are we feeling? Good? All right. So, you know, we want to prevent accidental loss. We have a bunch of data we care about. We just learned that RM can be scary. So how do we prevent ourselves from losing things we care about? One way to do this is to back up your files on an external hard drive. You can modify your personal Linux environment or Unix environment, and you can remove your own write access to the files themselves. And we'll talk about that tomorrow. The first couple of these we'll talk about today. So we want to back up a file, or we want to back up a directory. We've been working on a bunch of data. We're really happy with an important intermediate point that we've processed our data to. Maybe we've mapped all of our reads to our reference genome. We've processed those BAM files. We're ready to call variants, but we want to save those files in that kind of state in case something else happens. How do we do that? We can just copy them all over to an external hard drive. That's fine. Although, you know, you're going to find as you start moving large files back and forth or large folders back and forth, it might take days to move things back and forth from each other. Like that's a very realistic issue to have. You know, I sequence a bunch of stuff on a NovaSeq. It might take me, you know, 12 to 30 hours, depending on, you know, how the speeds of where that was put together to even move it once. And I don't want to be doing that all the time. So we can make backup copies of files in compressed tar format. And so the tar format is basically information that preserves the directory and file systems of what you're working on. And then we're going to zip that whole thing into a nice little compressed, what they call a tar ball. And you know, here's a little joke, if we can maybe see it. You know, people always forget tar commands. So this is xkcd where Rob, use Unix, come quick. We have to disarm the bomb and enter a tar command in your first try in 10 seconds without Google. Rob, Rob can't remember. The command's always, because it's a little complicated and it's sometimes fickle about the order things come in. But the general syntax of creating a tarball is tar. And then we give it a bunch of flags. And here we're going to say compress in C, Z for zip. V is verbose, so it's going to let me see what it's doing, and F is file. And here then we're going to have to feed it where we want the tarball to be created to, new.tgz, and then what we want to work on. We want to work on the file new. So if we have this here, we can do tar CZ VF, and I don't believe the CZ and V order matters. The F does. That always has to have last. You're telling what file you're working on. And it told me, you know, this is verbose, what it was working on. And so if I type ls now, I have now this new TGZ, and that's going to be a compressed, kind of preserved version of what's in new all at once for me. So if that's nice. And I'm just going to use B. And some of those we can get to at our next little break or whatever. And so how do we then get that from Hoffman to where we want to be? There's a number of ways. We can remote copy files using secure copy. And this works for us really well if we have either a Windows or not a Windows, a Mac or a Unix machine that we're working on. And so the general command is secure copy. If we want to put something to our Hoffman cluster, we're going to feed it a local file. And then we're going to tell it, you know, user.hoffman, this is going to be our whole login information, and then a colon, and then the path to where in my Hoffman account I want to put that file. I can do the exact opposite. So I can do secure copy user hoffman2.idre.ucla.edu colon, the path to where that file or directory is, and then where I want that on my computer. So that's one way we could do this. And let's see. All right. We can use FileZilla or WinSCP. I like FileZilla because it gives us update stuff. And the other thing I like about using on a Windows machine, you can use FileZilla on Macs or Linux systems as well, is secure copy. If your interruption gets broken or your Wi-Fi blips out or whatever else happens, whatever was happening, whatever process disappears. WinSCP and FileZilla generally tend to have some sort of memory about where and what you're transferring things to. And so if your Wi-Fi blips or you have to pause the transfer to go home, it actually remembers where in that transfer you were and restarts it for you at kind of a safe pickup point. So I like that. If you're using WinSCP, you create, you basically start it, log in, create a little new with a Hoffman, or call it something, a new program or a new transfer. You put in the host name, Hoffman2, IDRE, UCLA EDU, the port number, your username, and your password, and you hit save, and it'll save that session, so then you don't have to enter this every time. And then you log in to that thing, and it'll get you set up and log you in, and then it actually lists both file directories or systems. One of them is Hoffman, and here you are on your home computer, and you can just drag things back and forth, and that works pretty well. And so it's the same thing if we want to use, or very similar, FileZilla, which I like. And of course, wants me to update. So so Hoffman 2, IDRE, UCLA EDU, my username, my password, my port, and the port here is going to be 22. That's Hoffman's port. That's what that's set up for. Come on. And then I'll hit connect. It's connecting, it's resolving. It's now here we can see it's opened up. You know, here's my file system to where I'm at on Hoffman. You know, I'm over here in downloads or whatever else. I can scroll through and I can, you know, I can click through these file systems, or I could type them out if I wanted to as well. So I just moved to my desktop on this computer. And then I can see here's test. And here's that new tar GZ. And I'm just going to drag it right over here, and it'll give me a little cue that it's queuing that up, it transferred, and it's done. And so now I've moved stuff back and forth pretty rapidly. I get a little notice that it's finished successfully. And so we can see all that stuff. And so hopefully that works pretty well for us. And that's, you know, a pretty easy way to move things back and forth without having to use secure copy. And most people like using different file management programs because, you know, like I said, they have the added benefit of being able to, you know, pause or stop or pick back up, where you can use secure copy if you want, especially if you have a Mac. But if the interruption gets, you know, interrupted, or the connection gets interrupted or something like that, or you shut your computer off or something else weird happens, you might not even necessarily know that file transfer didn't finish, although it'll look finished and fine. So most folks like using some sort of file management protocol. Hopefully that's okay. And so we've actually been keeping way better pace, or a much more rapid pace than I expected us to. And I don't know if that's because hopefully I've not been going too quickly. Folks have been following along okay. I hope. If not, I'm sorry. But what I think I'm going to suggest then is we're going to talk a little bit more about a few last things about setting up aliases and that sort of thing. And then maybe, I know we're ending quite a bit early. In person, this would be kind of pushing the envelope at 12. And then maybe Nathan and I can stick around and try to help folks resolve issues if that works for us. And hopefully that works okay. So one other thing we can do, and this kind of helps protect us from deleting things on our computers, and hopefully these are helpful, is we can modify our Unix or Linux environments to do things like add prompts or confirmations for when we want to delete or overwrite a file, for example. So copy, move, and remove all have a flag little I, which stands for interactive. And all this does is actually ask you, hey, do you want to do that? So I can do move I test rename text into large text. And so here, the default behavior, if I moved test rename to large text, it would overwrite large text. and whatever's in large text would disappear. And that's the default behavior. And I'm not going to do that, but the flag I is basically giving me an interactive warning when I'm trying to do something stupid to myself. And so here it's actually saying move, do we want to overwrite large text? If I did this without this flag I, it would just move test rename into large text. Everything in large text would disappear forever. And I might not necessarily even know it. It wouldn't warn me that would be happening. And just to kind of, so I'm going to hit N. It eventually did that there. And so if I type ls, hopefully it's there. I'm just going to show us just because. So if I just did this, I've lost that file. Large text has that in it now. It doesn't have the numbers 1 through 300. Bummer, right? So we, like the idea that this, move is interactive. I can do the same thing for RM. Are you sure you want to delete this? And so those are nice, nice things we can do. And what we can do is we can actually create aliases, sort of like a symbolic link, on our own profiles that change the default behavior of copy, of move, of RM to copy, move, RMI. So we're basically changing the default behavior of these tools to something that we want it to be. And we're going to do this by editing the bash profile. And the bash profile is information that's in our home directory that basically tells the terminal how to interpret what we're typing to it. Do we want a minute? I can't see. All right, it looks like, all right, I'm gonna wait for us for a second. It looks like a bunch of folks are stuck on FileZilla. So I'm gonna, and this is the sort of thing you should only have to type once, but I'm gonna type it, I'm gonna show us again. I know the text is a little small here. So once you've done it before, if you do this quick connect, it'll actually save the information for the things you type or where you're going. So the host is always the name for, or the path or address for where Hoffman is. So here, hoffman2.idre.ucla.edu. The username is going to be your specific username. The password's your specific password. Port in this situation is 22. And that is the Hoffman specific port. Some computers with higher or lower security might have a different port, but 22 is almost always default. And then we'll hit quick connect, and it's going to ask me, do I want to abort the previous connection because I'm already connected? And I say, okay. And then now I'm connected to Hoffman. It kind of leads through, and it gives me this whole file system directory listing here. And there's many ways we can navigate here. We can either click. So if we wanted to click into test, I can do that. And so now I'm in test, and now what I'm being displayed is what's in test here. And you can see, there's these new directories. I could also type the path if I wanted to up here. So now it's actually changed. So now I'm in new. And over here is everything that's on my computer. So the same way I can navigate around all the file systems, to my desktop, my documents, what's on my computer. And then if you wanted to, example, move something directly to a external hard drive, if you had one plugged in, I don't right now, you could maybe see where that would be, for example, as well. And so then if you want to move something back and forth, You know, I could just grab whatever I wanted. So here's, and when I'm doing this, I'm copying, I'm not moving them permanently. So remember we created that tarball, new TGZ. And so if I brought that over to my desktop, and here I've already done it, it's going to say, oh, do you want to overwrite this? And it's actually warning me. And so this is copying new TGZ to my desktop. And so once you copy it and you know you've copied it well, if you wanted to, for example, remove that, you could remove it safely from your directory in Hoffman and know you're in pretty good shape. So hopefully that worked for us. Double check. All right. All right, so I think we're in good shape. So the last few things then that we're going to talk about are aliases. And so like I said, you know, we can create these default behaviors, and we can do that by editing our bash profile. So if we go into, if we type cd tilde to go home, I'm going to make this larger. So you can type ls, and you can see I have lots of stuff here in my home folder because I'm a disaster. If I type ls flag a, and so remember this is going to display everything that's there, we end up with a whole bunch of extra stuff being listed, and these are all either folders or files that start with a period. And so these are things that are information about how Hoffman is interpreting what we're typing to it generally, or how it understands how we expect it to behave. And so the bash profile is a file, it's just a text file that basically tells the bash terminal how to interpret what we're talking or what we're typing it to it. And so we can scroll up. We can nano, and we want to be careful though, because of this, that we don't do bad things to our bash profile, because that's going to, you know, seriously affect, you know, potentially our ability to use Hoffman successfully. Although, you know, there's always ways to fix things. So if we nano the bash profile, we're going to notice a few things. The first of which is there's a lot of things that you know, start off with hashtags or pound signs. Those are things that are information for us about where that aren't interpreted by the computer. So every line that doesn't start with a hashtag is read by the computer, and we can then create aliases, for example. And so here I've actually given myself, and I've already written this because this is not the first time I've taught this. So I've given myself a couple pound signs and says, this is to ensure RM always asks me if I want to delete a file, and some other stuff. And you can see I've actually already written the command alias RM equals, and there should be no space or anything between the equals and the quote RM flag I, end quote. And so now what I'm doing is I'm creating an alias. So now once I close this, every time I type RM, the computer knows I actually mean RMI, which is hopefully useful for us. And so then we can exit, and we want to save this buffer. So you could type that. I'm saving it to the bash profile. And so, you know, just like, you know, I'm only doing the RM. If you wanted move, if you wanted copy to also be interactive, you could add those lines there for yourself. And then we need to reload that bash profile. And so there's two ways to do that. The first one would be to log out of Hoffman and log back on, and then that would reload all the information in that bash profile. The other thing we can do is we can actually source that bash profile and hit enter. And so then it actually should know that I've created that alias. And it's reloaded that into my current environment. So if I do cd, I'm going to go back into test, and I want to rm large.text, and it's asking me, do I want to remove that? And so now I have this new default behavior for RM that I've created. And if I want to remove this behavior, I can either remove that line from my bash profile, that alias line, or I can put a hashtag in front of it to comment it out, is what that's being called. And I don't want to remove it, so I just type no. If I wanted to remove it, I would type Y for yes. How do we feel about that? Are we doing okay? Hopefully. Come on. Yep, and yeah, that's a good question. You only need to relog in or reload that that profile every. What am I doing? Every time, or every kind of fresh time you work there. So that's correct. All right. All right. So like I said, now we can type, move with that alias or RM, and it's going to actually prompt me with that interactive queue. So like I said, I think we've actually gone quite a bit more quickly. Maybe being online is faster. But hopefully we've been keeping up and stuff okay. So hopefully though, today we've kind of learned about how to report our current directory with path working directory. We've learned how to navigate around a file system, how to copy files, how to copy and move or remove directories, and how to make new directories. And so for example, if I kind of gave us this task, create a directory called practice. Inside that directory, create a couple files, copy those files, remove files or delete files that end in, B, for example. Could we do that? And hopefully we can. So I'm going to actually vote then. I know we're getting out early, but I think that